So I believe the recording has started. Yes, it did. So hello, everyone, and welcome to the GeneStack webinar, to a series where we talk about how to manage your data in the best possible way. My name is Fatima. I am a solutions consultant here at GeneStack, which means I work with the clients, helping them to manage their data, but also I do my own research. I'm really passionate about it as I have a background in biology and data science. I do lots of different types of research on public data, and for all of that, I use our own platform. So today I'm going to be talking mostly about my experience, how I manage my data to make sure it's seamlessly integrated with all the services that I. So let me share my screen and we can get started with that. So the topic of today's webinar is how to streamline your data flow, which means how you use automated and software-based processes to speed up your workflows and a so-called data liquidity. We're gonna explore this term later on. So when it comes to data flow, three main important things are there. So one is data import. It's about ingesting your data and attaching all the related files that you have. So for example, in our platform, in this webinar, I'm going to be talking mostly about our platform and how we manage it. So you can get the inspiration and understand some of the best practices of how it's done. But also maybe you will get interested in some of the ideas that we propose or want to explore our platform further on. So I'm going to be talking about the data import regarding our system and tell you about how we can ingest any tabular data that is present in the world and attach raw files and related documents and the platform. The second thing I'm going to be talking about is the connection to other systems, because we really understand that our platform is not the only one that you have. You probably have your own systems in place. You have your downstream apps, upstream apps, and everything like that, your storages, your LIMS systems. And you don't want another system to be just a part of this clutter. You want it all. You want the system to collect all that systems together. So this is what Open Data Manager is. So again, it can connect to any systems that has API. You can import and export data automatically. And the final part is the most important one to me, because there is no point of having data if you draw no insights from it. So we're going to be talking about the data analysis. We will see how you can use any available software apps with API support or create your own apps using your system. So let's go ahead and get started with the data import. So when it comes to data import, one important thing is that to be able to ingest as many data types as possible. Because if your system only supports certain data types, like it only supports the GCT files, it only supports like the BAT format or something like that, you're not going to have all your data in one place, which is the main reason of having a data management system, right? So when it comes to data import, having as many data types supported is a huge advantage. And this is actually a sneak peek to our new function, our new release, where we made it possible to ingest any tabular data with any type of analysis, like the biomarker data, your metabolomics, proteomics, transcriptomics, etc. Anything that comes in tabular format can be ingested into the system. And anything that is not in a tabular format can be transformed to that tabular format and ingested as well. We had experience with JSON formats, XML formats, etc. So what are the ways to ingest your data and how you should do it? About 90% of our clients will do that automatically, because as I already said, they don't only have our system in place, like the only one system they use. They will have a whole bunch of systems, again, like the storages, the metadata and ontology services, and they want to connect them all together as seamlessly as possible. Because if you have to draw the data from one place to another manually, you're prone to errors. It will take your time and effort and cost money, therefore. And that's why you have to make sure that you have the ability to load your data automatically. So this is the first way in which you can load the data to our system. It's automated loading. So all you're going to do is you're going to connect your other system to the ODM using some sort of API endpoints or data transformations. And then once the new data appears in that system, it will automatically get thrown to our system, to ODM, and be stored there, right? So that's, again, the 90% of all use cases that we have in our company. The second thing is loading via the graphical user interface. That has its own advantages. For example, you are a biologist and you're not familiar with the coding at all, but you want to load just a single data set and see how it goes. And you want to do it quickly without any troubles. You don't want to write any code for it. You don't want to do any connections, right? It's a one-time thing. You want to just load it via the graphical user interface in that sense. You can definitely do that. We have the graphical user interface where you can just click the create new study button and then select everything. It's a guided process where you select the type of data you're loading and then how to link it, etc. So it's very intuitively easy, but again, it's one option, which is really good actually to load historical data, for example. So you don't have to connect your system and spend a lot of time writing code. You can just do it using the graphical user interface. And the last way to load your data, the one that I use the most, is actually using a script, right? Because I'm a bioinformatician and I code a lot and I'm comfortable coding, I will load my data using the command line. And for that, in our company, we have a script that will just accept the links to your files. And once you run that script, everything will be put into the system. It's really easy and simple. And I'm going to show you how I do that in the live format, right? But before we do that, let's quickly see the system, the interface of the system. So here's the study browser, a place where you have all your studies in one place. So what is a study? Well, a study is something like a single data set, a single experiment, or a single research paper. So you understand the concept. And here you have all your studies that are loaded to the system. Like I have 42 of them. Such a beautiful number, I love it. And on the left side, you have passes that you can use for quick search. For example, I can retrieve all the data sets that were loaded from the TCGA just by clicking this button. You can also select the studies that have certain access rights and certain signal types, etc. So this is what passes for. You also have the search bar up here that supports all sorts of search. It's a synonym-aware search, which means if you type in cancer, you will also have the carcinoma results. And it supports logical operators, ontology search, etc. So it's really powerful, not just the exact term search. But let's quickly explore one single study. Let's, for example, select this one, this thyroid cancer study. As you can see, if I click on it, I'm going to go to the metadata editor. So this is a place where I have my metadata, obviously. And you can see here that this is the study level metadata. I also have the sample level and the expression level. And under the study level, I have the study source ID, where if I click on it, I'm going to get the source of the study. But I also have lots of files attached to it. So those are some sort of analysis that I ran on this thyroid cancer data set, some reports, etc. So it's all attached in the system and it's all in one place, which is really cool. And if I go to samples, I'm going to get the samples of this study where I can do the filtering, etc. So this is not the point of our webinar, to explore the system. But one quick thing that I wanted to show you, one thing that I'm really passionate about is that you can attach raw and process files right into your sample metadata. This is what I do all of the time. So here's the example of a different study. In that previous study, I did not have any raw files, but in this one, I have both raw files and process files attached to the sample metadata. So each sample will have its own FASTQ file and also becomes it some sort of a analysis file as well, which is really cool to me. Let's go back to our study browser. Just to confirm, we again had 42 studies, and now we are going to load a new study. Let's do that together. So here I move to the terminal, and I am going to input a query, a command that will load a new study. Here's how the command looks like. So here I have the Python script that says ODM import data. This comes with the system. When you install the Python package, you'll have all sorts of scripts, not just the loading script, but also the curation script, etc. I have provided my token here and the name of the server. So this is the link to the server. And then I specified, actually, let's run this first and then talk, because it's going to take some time to load. So here I have my study level information, my samples, my expression level of information. So here I have my RNA-seq, gene expression RNA-seq, the copy number variation, and gene expression RNA-seq normalized. Those are the three types of data that I load. And I put NFA1, which means this is a specific term to indicate that you only use the first column of your file as an identifier, because you can have multiple columns of identifiers. And here I specify the template, which is the controlled set of terms that I am validating against while I load my study, where I have all my dictionaries and scientific ontologies attached. And I put allow duplicates because I have already actually loaded the study and I want to make sure the system ignores that. And while we were talking, the study has loaded successfully. You can see it now gives me the unique accession of this study. I copy it and I go back to the system. I can input it here and I'm going to find the study that I have just loaded. So here it was how we load our studies. Just one way to load. You can also have automated loading by the graphical user interface, but this is what I do the most. Okay. So just loading a study is not enough, right? You just loaded one study. You also want to be able to retrieve it and to have it well connected with the other systems that you have. How do you do that? How do you achieve that? Well, again, as I said, once you have your proper APIs in place, you can use them to build basically any sorts of complicated connections between your systems using the ODM. For example, in our platform, we have the RESTful APIs. We have the Swagger that helps you use those APIs. We also have Python libraries and R packages, which means you can use Jupyter notebooks and create R Shiny apps we can export later on. And also we have ready-to-use scripts like the one that I just showcased you before, the loading script, but we also have the curation script, etc. So you can have the ready-to-use, frequently used scripts right away without creating them yourself. And here on your left, you can see some non-exhausted list of possible connections and systems that you can make, the relationships that you can make when you have the APIs. So let's explore them one by one. So this is the first type of connection that we usually do for our clients. It's when they have some sort of a bioinformatic pipeline in place in some server, and they want the data to come from ODM to that pipeline, be processed there, and the resulting files should be saved back to ODM, so everything stays in one place. And again, it should be all well automated. Again, the data is taken from ODM, sent to the pipeline, and when the pipeline is finished running, the results are sent back to ODM. This was successfully created for 2 of our clients, and it's one of the most popular requests that we get. And again, it's possible thanks to the APIs that we have. It will be created this will be implemented using the Python script that you will automatically do all of that without you even noticing it if you want. The second type is when you have like many-to-many relationship. So you have many data sources. Here I have listed some public data sources like Geo and DCGA, but you can have your own private sources, and you have several analysis apps, and you want to connect them all seamlessly. And even more than that, you want to search across different data sets, right? So again, it's data from multiple sources that is entered into ODM. It's harmonized in the same way, so then you can use the cross-study search. You can use that using automated scripts, and then it's sent to multiple analysis tools like Jupyter Notebooks, R Shinies, or other apps. Again, this is possible if you just create the rules, create the scripts that will connect this all together. But with the public data, it's usually like your different chunks of data will sit in one place, like your metadata, your raw data, it will all be in one place, which can be different for your internal systems. For example, you might have the ontology service in place as a separate system. You'll have your metadata storage as another system. You're going to have a raw data storage where you put your FASTA, FASTQ, FASTA, and again, it will be a different place, a different server. And you want to connect them all together. But it's not just inputting many different sources again, but this time it's connecting them all together. Again, it can be checked with our system easily. You can just have the automated processing using the APIs of our platform. So once the data is being ingested, it will just transform it, it will connect it, make relationships, and input it into ODM. So again, it's automated processing scripts that you can use thanks to APIs, and you will gather many chunks of data together to harmonize and put it into ODM. So this is another possible scenario of a connection that we actually use a lot. We actually have it a lot, right? And finally, so we talked about the data import, we talked about connecting multiple services, but what about actually getting your data work? Because in the data-driven world, it's not that important to have a data, but rather to be able to use it. If you have very valuable data sets that you don't use or you can't use because you don't have them easily available, it's the same as not having data, and all the effort put into gathering that data goes into waste. But we at GeneStack want to make sure that all your data sets are valuable, easily accessible, and interoperable. And to ensure that, again, we have APIs, and we can connect to any other tool that has APIs. For example, for analysis, you can use any available analysis software that has API support, or you can create your own. Again, as I mentioned, we have R packages and Python packages that will be used to create R training apps and Jupyter notebooks, but you can also use another systems that has APIs just to connect them and to retrieve data from ODM. We have examples for all three of that. For example, we have the analysis apps that we connected with for our clients. We have our training apps that we created internally and for our clients again. This is just one example of them. This is the app that does some sort of a single cell analysis. But we also have the Jupyter notebooks. That's my favorite part. So let's explore Jupyter notebooks for now. So here's an example Jupyter notebook that we created recently. And let's see how the API calls work. So for example, in this analysis, what we wanted to do is we wanted to get the expression data and get the variant data, and then to join them together. This is done across multiple data sets and to drive some results. So what we're going to do is we're going to import a library that we have. So it's called the Integration Curator library. It's a GeneStack library that we created to access our system without even opening it. And first we get samples. So what we're going to do for that is we're going to call a function, and we're going to provide the filters for study and sample level metadata. So for study level metadata, we want to get all the studies that come from Geo and are about Homo sapiens, humans, us. And for sample filter, we want them all to be males. As you can see, the call is really simple. It's just 3 lines of code. It's 2 lines of code if you do it like that. That's the way you retrieve your data programmatically from Jupyter notebooks. We do the same for the genotypes and for expression data, and then we collage them together and draw a plot. This was an example in Python programming language, but exactly the same thing can be done in the R programming language, because again, we have 2 different GeneStack libraries for Python and for R. So again, the syntax is slightly different because it's another language, but the things that we use are the same. We again use the Integration Curator package from the GeneStack client library. We get the samples, we get the genotypes, we get the expression data, and we plot them all together as a box plot again. The box plot looks a little bit different again because it's our programming language. But here's just one simple example. We have way more complicated examples of Jupyter notebooks, but that's not the case. The message here that I want to get to you is that you can do your analysis using our system without opening the system, using Jupyter notebooks easily because we have the packages in place and we have APIs. Right, so that was the analysis part, the most important part of all, because the better it is, the easier it is for you to drive your results from the data, the more productive you are, the less time you spend actually processing data, cleaning it, and trying to find it, and more time you spend analyzing it. This is what the Open Data Manager takes care of, so you can focus on driving the results and making the world a better place. So that was it. That was actually everything that I wanted to talk to you about in this webinar. And thank you so much for your attention. Please feel free to go to our website, genestack.com, where you can request a demo, a personal demo, you can click through the system. If you click the request demo button and put your contacts in, you'll be able to click through the system yourself, right? So just in your browser. Or you can contact me directly so we can have a further discussion about how you should work with your data to make it more efficient. But again, thank you so much for your attention, and I can't wait to see you in our next webinar.